Hello. I did a little bit of thinking, and I think we're fine. So the problem that I sort of left, I should provide some context here since this is start of stream and therefore start of VOD. We left off working on prioritized experience buffer for PPO, and I thought that I've got this working idea that on policy versus off policy, it's kind of all a lie. Um, oh no, the data is off policy really doesn't matter that much. And I found one spot that kind of throws a wrench into it, but I think it's still fine. So the idea, and there will be an article on this, is that in PPO, or I mean policy gradient methods in general, you take, I guess the formula is not going to be in here. Basically, the formula doesn't depend on the old policy at all because you're computing new logits. So there's actually, if you look at the math, there's nowhere that the old policy is even remotely involved. The one thing that is implicitly involved is that the value function gets stale. So the value function is trained to predict, well, one form of it is trained to predict discounted rewards under the current policy. So the value function is just going to undershoot a little bit. It's just going to undershoot the current policy a bit. I don't think that should be a problem. It's fixed. The amount that it's going to undershoot by is fixed because the policy can only improve so much from one batch of data, right? It can't infinitely improve. The value function cannot become infinitely stale. So I think this is all fine, and basically the results that we're seeing where this isn't immediately working out of the box, welcome to reinforcement learning. Things don't always work immediately out of the box. I think it's fine. We're kind of seeing what we expect to see here, and we just have to tweak a few things is all. So this is 1024. All right. So what I want to do here I want to change the replay buffer to only be half of the batch size. And we will go from there. Let's actually log as well. But we're not going to run experiments all day today. That's really, really boring, and I just don't feel like doing it. So I mostly want to work on getting this file nice and clean today. And there are lots of things that we can do with that. We can definitely improve the kernel today. I don't want to think about putting this into a class or not yet. We're going to punt on that for today. We can get E3B and diversity all you need running on the new code base. That would probably be useful. We can look at a little bit of the logging stats and stuff. And maybe at like some of the aggregation code. I think that will probably be enough to get the code base into a good state. Should be enough to get the code base into a good state. There are a couple quick experiments though that we can run. And if we get stuck, we can kind of just like punt. So if I just turn replay off, You should just be able to disable this thing, right? Reprioritize the experience. Yeah, you don't need this. If okay. Because this might not even be like the on-off whatever policy bullshit. This could just be something way simpler. Ep uses. Data.ep uses. Let's just do this. Okay, there we go. So this is now no stale data, but prioritized experience. Or what is it? Advantage filtering, basically. Prioritized advantage filtering. And this is the baseline, which is random. So far, so good, actually. And it's not bad. Do you need to use... That's all we're going to really need to do on the experiment side, depending on this result for now. We'll leave this, and then we'll look at CUDA, I think. We can look at a bit of CUDA. CUDA's fun. Oh yeah, there we go. So what is this? PyBind torch extension name. Do you need to use this? I don't think you need to use this, do you? Oh wait, you have this like weird... Okay. The one thing I will use Grok a little bit for is like new libraries and binds. Because I have not done really much at all with PyBind, and I don't know if it's necessary. I'd be surprised if it's... I see, so you can do it. Is this that bad? Oh wait, you can use PyTorch build tools. Okay. So you can actually get CUDA extensions here. This like with PyTorch implicitly uses PyBind to create the Python bindings. You don't manually define PyBind 11. So you just define this. So that's basically the same thing. Is that better? Or is that the same bloody thing? Oh, also, yeah, there we go. So, advantage filtering, nice and clean. Questionable whether you get anything else from the prioritized replay. That seems to break stuff, but that's fine. Okay, now we do some CUDA stuff for a bit. m.def. This is like the same bloody code, isn't it? Yeah, there's the same exact code. How do I have this defined right now? I guess I don't have it defined in here. Load. Okay, so this is the thing. I have it right now just in here instead of in the setup.py. How would I set this up to? How hard is that? Precompile for specific platforms and CUDA versions. Okay. Yeesh. Yeah, so that's a little annoying. Distributing these is a bit annoying. So we're not going to deal with that just at the moment. But that makes sense. Not missing anything, right? All right. The one thing I think we can do here is we can move all this code from Python into C or C++, whatever it is. If you allocate the tensor in Torch, is it just fine or no? Compute advantages, compute JE. So right here, we can kind of do some stuff, right? So we do int steps stuff size probably, and then torch. I'm going to assume it's auto-completing Torch API here, and we'll fix it if it's wrong. Then it's, what is it? It's synchronized at the end. I don't know if that's automatic or not. What's the plan with JE? So since we're shipping our own implementation, we need to, ideally, first of all, I don't want to have a big annoying binding in the Python file. So we're shipping a PufferLib.cu or whatever. I don't know why it's a .cu, honestly, for this, because it's a binding file. That's kind of weird. Anyways, we need to figure out how to make the thing that Torch does, essentially, where you have a C version and a CUDA version, and then, it falls back to the C version if you don't have CUDA. So we're going to figure that out today. That'll clean up the clean PufferL file a little bit, and also will let us run all this nice new stuff in CPU mode. All this is figuring out bindings, like the actual code. You literally paste the CPU code versus the GPU. It's the same thing. So that's easy. It's literally just binding hell. The only tricky thing. Figuring out how to do this will also be useful though for P30, because we're going to need to do the same thing down the line. Basically, this will all get you reused. I don't think you need to call synchronize. I also don't know how this works with AMP. I'm just going to paste this into Grok for an API check. Wait, why is there a def in here? Dummy. Having a lot of connectivity issues on box 2. Running sweeps and offline manually syncing is banded for now. Okay. Also, make sure when you log in, there's a disk space usage. Make sure you're not getting up to 100% utilization. There's like a torch bug that's causing the model checkpoints to blow up, so I had that happen. I'm gonna have to take a few hours at some point soon to like go through all the machines and see what's going on. I think it's straight up just ISP. It could be that a cable got damaged as well, but I really don't know. It's a total pain in the ass. %, yeah. It should probably be like 4%. So my guess is just the checkpoints. The checkpoints are huge for some reason. I was getting like 2 gigabytes per checkpoint or whatever with Neural MMO3. They should be like megabytes. Okay. Replace this with this. Device. What's the D type of device? Oh, I actually don't like the way it wrote this at all. You don't need to worry about manual memory management because smart pointers, blah blah blah. Cool. That's fine. Get device. Launch there. Okay, I hate C++. This code sucks. Like, what the fuck? Tensor options dot dtype dot device. Programmer who decided this is a good way to set options needs to be shot. Good thing this is only the binding file. Because holy hell, this is horrible. I don't think that this is a float, is it? How do I make this work? Do you actually have to do AI dispatch? What the hell? At dispatch. But now the CUDA kernel isn't gonna be good, right? Maybe we back up on this. Yeah, let's do that. Okay, so does this now work? Well, I should no longer need this. What's wrong with it? Eesh, this thing like fails on const, really? That's really strict. Alright, well, we're just going to accept that this code's going to be awful. There's no real way around having that binding code be awful because it's PyTorch C++ API. It's written in idiomatic C++, so if you want to interact at all with Torch, yeah. The only alternative would be to do all this checks on Python side, but then you end up adding more annoying Python. At least now we get this D-type stuff, right? What's idiomatic? Well, it depends on if you like C++. I personally hate C++ and think it's a disgusting language. So pretty much anytime I have to interact with it at all, it's just like throw up my hands and there's no way I can make this code nice. There are just so many things about C++ that are just horrible, horrible software design. Ugh. Hey Joe, what do you think of the new llama models? This may surprise some people, but I do not keep up with a lot of the new model releases, like, at all. It really doesn't affect me one bit. Like, the new models are kind of doing some simple RL now in a way that doesn't affect anything that I'm doing. And like I say, all the major labs are just gonna like keep leapfrogging each other by a few elo points for the next, like every couple months for the next who knows how long. It really doesn't change any of the way that I do my work. It doesn't really change much of how I think about anything, honestly. I don't know, if Grok ever gets to be like so far stale behind the other ones that I would like get some benefit out of switching, then I'll switch to whatever the best one is at the moment. But other than that, there's not really like a big reason for any of it. I pretty much use Grok to like semi-vet research ideas, but not really because the paper search isn't great. I use it to quickly convert ideas into LaTeX so I don't have to type it up. And I use it essentially for like APIs and things I'm not familiar with yet. That's about it. Why is this? Why is this not float? Oh, because compute GA. Yeah, you don't need advantages now. Yeah, this goes away. So we get rid of this. Fill up advantages for you and return advantages. Welcome, folks. Fair few across YouTube and Twitch now. What we're doing right now, we are working on the new prioritized experience replay buffer for PPO. That required us to write a CUDA kernel for GAE because GAE gets called way more often now in this new code. And we are currently cleaning up and getting the CUDA kernel to work nicely, get it nicely bound. And then we're also going to have to do the CPU fallback, which is a C implementation. It's actually the same code. We're going to be able to do that very cleanly. But that's what we're doing at the moment. Just jamming some low-level dev for Puffer. Generally having a good time. Values, rewards, duns. Float, int. Ah, you don't need this either. Steps, horizon. Int. You mentioned yesterday on versus off policy is a myth. Can you explain that? Confused as I've read on policy priority replay doesn't work or is tough for a while. Well, I could be wrong still, but in what way does off policy break this? I don't see anywhere where off policy breaks this, right? So it's not easy to see from this math definition. It's a lot easier to see from the code. Let me show you the code. Because they use like fancy ass notation. Okay, so here's the policy gradient loss, right? PG loss. Okay, so it's advantage. Advantage doesn't get a gradient. So advantage is like essentially a constant times ratio. Ratio is log ratio.x. Log ratio is new log probs minus log probs.reshape. Oh, hang on. Maybe there is a PPO specific thing. This is not in vanilla JE. I mean vanilla gradient estimation. No, because this is still clipped. Hang on. That's only for a prox KL. Okay, ratio. God damn it, now I'm confusing myself. Oh, well, because this is a constant. I went through this the other day and I found something with it, but now I'm trying to find where the frick, like where was the nice clean version that I was looking at. I'm trying to remember if I looked at the GAE paper, the PPO paper. It was the PPO paper. Yeah, okay, so this is just the clipping term. The old policy is only used for the clipping term. And the new policy is used on the state and the conditioned on the actions. So this is getting new logits using the new policy. So this clipping term is irrelevant then, because this is essentially a constant. This advantage term doesn't get a gradient, so this is not backpropagated through at all. So this doesn't depend on stale date, like this doesn't depend on anything stale at all, right? The reasoning that I went through a while ago was it's a like the usual reason given for like, oh, it's stale, like stale data is bad. It's like the data comes from the old policy. But the thing is, you don't use the logits from the old policy here. You use new logits. You use updated logits that you compute from running the forward pass again. So basically, I don't see anywhere where off-policy data would screw you up. And as a counterpoint, PPO is immediately off policy anyways after their first mini batch. I was even starting to wonder if you can delete the clip term anyways. Like, I'm suspicious of the thing completely crashing without clipping. Oh yeah, it's dominated by one experiment. What was I doing here? D1. I do not know why it formats my code this way. Horrible code formatting. Yes. Okay, that runs now, yay. Now, how do we get this to be a fallback? We have to get this to be a fallback. Use conditional compilation in the binding. je.cpp. Let's see. See, the problem with getting stuff like this from Grok is I don't know if the code is just generally, if the state of like binding code is genuinely this garbage, or if it's just Grok being bad at coding. CPU implementation. Okay, so they have, it's funny it implemented JE. Worse than my version though. JE. If def with CUDA. That's kind of awful. Oh, it's still doing the garbage. It's still doing that garbage, like, AMP thing. Okay, so compute JE. This is all the same. Do you have to frickin' macro it? That's like disgusting. Okay, so here's your JE CUDA kernel. Okay, this is potentially better. We rely on the build system to include or exclude the CUDA file. je.h. So this is attempting to be weird. It just has this structured weirdly. It's going to take me a few minutes to figure this out. And then what is this? Extensions. Oh, but this still doesn't work. Oh no, it does. So let me see what this is. So this is the binding file. Declare both. Oh, but then they're using like repeated declarations. That's really obnoxious. That's really obnoxious. It's funny how it's always toolchain crap that's like the hard part, right? Writing the kernel was super easy. If def with CUDA. Oh wait, does it need 4 declarations? Shit, it does need 4 declarations, doesn't it? Oh, that's annoying. That's really annoying. Is there a good way? I mean, this has got to be a solved problem, right? This is just like, is there a good way to do CUDA with CPU fallbacks without having to do a bunch of shitty forward declarations with conditional compilation, right? Like the thing I'm trying to do is very, very simple. Here. So, is it advantage? All right, so this is the CUDA file. Really, it's just this piece at the bottom. The plan is I'm going to take this and I'm going to just paste this into C, and then literally all this is going to do is call the function, right? Because this is just GAE. So this is tiny, And then this thing, all this needs to do is export one binding for the CUDA version and one binding for this the C version. So I should be able to end up with like a... Is this a CUDA file or a C++ file? This isn't a CUDA file. This is just named PufferLib.cu. This should be a C++ file. So I should end up with a PufferLib.h. I should end up with a PufferLib.cu and a PufferLib.c++, basically. Or not. Yeah, a PufferLib.h that contains the C implementation, right? I end up with a PufferLib.cu that contains the CUDA implementation, and I end up with this thing as well, this binding file. But the problem is you have to compile the CUDA. Like, if you're trying to use the CPU version, then the CUDA is not going to compile if you don't have a GPU. How does Torch do this? Is there like a clean piece of Torch code I could look at as a reference for this, or no? Yeah, so this is exactly what I want to do like this, right? I mean, could I conditionally import instead? Okay, wait, here's an idea, right? I could conditionally import instead. So I have I could end up with two files instead, right? I could have a PufferLib CUDA and a PufferLib CPU, right? That should make sense. The CUDA one can import the CPU one as well. Let me commit. Well, no, because it doesn't build in the current state, right? Does it build in the current state? If it builds in the current state, then we'll commit this up, and then I will mess with it. And I think I have a pretty clean way in mind of making this all work. Welcome, YouTube folks. Since we have some folks that just joined, this is currently getting a generalized advantage estimation CUDA kernel working with a graceful CPU fallback for PufferLib, because PufferLib is so fast that generalized advantage estimation can become a bottleneck. So I wrote it in C first, and now it's actually become so, it actually has to now call that so often that the C is the bottleneck, so now I have to have a CUDA implementation of it. And we're trying to get all this working cleanly in PufferLib, so you basically never have to worry about it. Yeah, okay, so this works. Let's commit this up, and then we will implement the thing that I have in mind. in PufferL, and then PufferLib.cu. Add CUDA checks. This is also a good time to remind folks to please start PufferLib on GitHub. It really helps us out. It's free. We're almost at 2K. Back to code. Okay, so this PufferLib.cu should be PufferLib CUDA.cpp. And let me make sure that that still works. CUDA. Okay. And then the idea is going to be that we take most of these checks go into the CPP. Oops, what did I do wrong? Global does not have a type name. Does this have to be a CUDA file? Oh, CUDA's the superset. Okay, yeah. So this does have to be a CUDA file. That's fine. So then that's even easier actually, because then this is PufferLib.cu. And then it's PufferLib.cpp. Easy. And then we make copy PufferLib.cu, PufferLib.cpp. Okay, and the CPP is going to contain basically everything that doesn't have to do with CUDA. And the idea is we're going to reuse as much of this as possible. And in order to do that, we need the CUDA code. Yeah, we need the CUDA code. So PufferLib.cu. Yeah, this code down here. We need this. So this is a CUDA function. How are we going to call a CUDA function from C++? We're not. We're going to do the opposite. What we're going to do here, we are going to do, this is void GAE. This takes a 1D tensor, horizon, same signature, right? This needs to know horizon, but no longer needs to know num steps. It's not going to have access to row anymore. So IDX is going to be row times horizon. That's nothing. We can actually just delete this line. And all we need is T next is going to be T plus 1. So this is actually even going to clean up the code a little bit. All right, and then you're going to see that this should work with both CUDA and C++ without us having to redo all the code. I mean, without us having to duplicate all the code. Let me see if I missed anything. Yeah, that should be fine. So this is now JE operating over a single row of the tensor. So if we pass in the pointer to a specific row, this will compute JE for that row. Okay? And I think that autocomplete might have even just done it for us. So values plus row times horizon, yeah. I think we want to do, oh, pointer, pointer, pointer. And this is offset, not pointer. That should be slightly better as well. Okay, gamma, lambda, and horizon. Perfect. I hate how it like expands this code to take up a bajillion lines for no reason as well. Okay. Yeah, this. So let's just clean this up so it doesn't take up a million lines for what is really a very simple function. And then you'll see that this is very compact. And then the idea is going to be that we will call the JE row is just going to get called from CUDA and C++ or C. It's technically C code. So that'll get called from both. And in this case, we do the loop ourselves. And for CUDA, CUDA is just parallel C, so it'll loop over the rows for us nicely with very minimal additional setup required. That's fine. And we should hope that the compiler inlines this for us. We might have to give it some encouragement, but it's probably not going to matter even if it doesn't, realistically. Advantages. Yeah. So that's it. These are the functions that we need. This is not going to include a C advantage. We do need torch extension, I believe. And let's actually just finish this binding right now. We're not really doing P30 yet, right? I'm going to get rid of this for now. We'll leave the CUDA version. We're doing JE. And I think we're going to clean up the way that this function is defined as well, because it's kind of silly the way it is. So we have device. We do all our checks. In fact, I think we're going to do check tensor or whatever. So we can do like JE check or tensor check and it needs to know, that's it actually, that's all it needs to know. We just paste all this stuff. Okay, so we're down to a very small amount of code here, right? We no longer need threads per block or blocks because now we just call JE, which is the CPU version here, on values.dataPointer float rewards data pointer float, done data pointer float, and steps horizon like so. Okay. And then we don't need CUDA errors because this is not CUDA. Okay. So it's going to look something like this. Now, these module defs I might have to fiddle with. But the goal is now going to be we import this file from the other file. So this is PufferLib CU. CPP. And then this C advantage, I don't even need this. Because this CUDA file can just go at the top here. Now you have your kernel. And this JE kernel should become simpler. Because this kernel is actually really just a row. So you have access to all the data, but you only are given a row. I should be able to rewrite this function to use that. This should be JE row. Oh, that works, doesn't it? I think that does work. Offset. We'll do offset, row times horizon. Set. Set. Not bad. And now we can get rid of this. This is the whole code. Because this is row parallel. So we just need to call from here, we literally just call the one row function and we're done. And as soon as we make these signatures not take up 10 pages of code, this will actually be pretty concise. And we don't need JE row because it's included. So this is our whole kernel. This is it. And we will leave the compute P301 alone there. We will add this compute JE. We have the validate tensors thing, right? Let's see, validate or check, JE check it is. JE check, yeah, like this. Forge tensor advantages, JE check, yep. Get rid of this. And then we have our kernel, right? And this is how it gets called. And then we do have the CUDA check, but that's it. So that is substantially more compact. Now, things I'm going to run into here, I don't know about that module def. Torch extension name M. Yeah, I might end up in like with like dual declaration or whatever problems. But let's see if we can get this thing to compile. Ay. Some steps undefined. Right. So this check has to get, let's do num steps, horizon. That way we don't duplicate this. Okay, and then we'll do the same thing. CUDA. Okay. All right, that works. The only thing I don't know how to get around is potentially the double module defs. We'll have to think about a second. The rest of this should just be a little bit of standard debugging to get this running. Okay, num steps is undefined. I forgot to include type. We don't need to include a CUDA check as well. That'll screw up the C++, but we should put it here. Get out of here, bot. I build the bots around here. Expected an identifier. Yep, messed that up. Twice. Okay, perfect. So we're down to only module def errors. So I have to understand how this module def works and how to not duplicate it, potentially. Can we defer? This thing did something that I liked before with the module defs. I don't know if it solves the problem, but it should clean it up a little bit. It's above this. Hmm. I asked about the Python API in here. Was that in a previous message? Or was it after this? That must have been before. Yeah, it was over here. Okay, so here you can take the functions out of this, which is worth doing, right? You can take the wrapper functions out, but you still end up with this def problem where you have declared the module twice. I mean, I could pretty easily just like put the shared stuff in a shared file, right? So then that's 3 files instead of 2. But I can solve the problem with that. Let's try that before I do anything silly. So PufferLib C++, PufferLib CU. What do I name it? JE check. It's annoying because I actually want to share like some of the C++ utils, I guess. Even though this is just C. Let's do, what is it, void or torch tensor. I think for now I name it something and then we'll figure out how to organize this after. So we'll just do this in shared. Right. Okay, so this is now in shared. Include shared.cpp. So now I have this binding here. You need the extension. And then I need to define these things because this is really silly. So this is void compute p3o. Just put all this code under here. Okay, there's compute p3o, and then this is going to be ampersand. Just do compute JE, and then we just take all this code, put this here. All right. So we now have a fair bit of stuff. I've been shared. This doesn't need to go in shared. This can go here. And now we should actually be able to compile this if I have not made any mistakes. And we will be able to conditionally load whatever extension. Maybe not the best solution, but this is a relatively simple one that doesn't require us doing a bunch of crazy for declarations. JE row is undefined in device code. Do these need to be marked underscore global or some shenanigans? Compute JE, JE kernel, and then this calls JE row. What if I do that? Global function call must be configured. What does that mean? You must specify how many threads will be executed. This is the launch configuration. Okay, so we don't want to do that because we just want to call it. So this should just be a C function. Host function. Runs on CPU and can only be called from other CPU code. Lovely. Global function runs on GPU. This is very silly. Of G. Underscore underscore host underscore underscore device. That's very silly. Okay, this now runs. Good. And it seems to be training correctly as well. So, now we see if we can import the CPU version and also try that as a fallback. If dot device. What's it? CUDA. compute JE equals so this can stay up top. Sources equals .cu. There we go. And then I just need to do, this is compute JE. Let's see if that works. Okay, this one still runs. Now we have to see if the CPU one runs. Main.device CPU. And we get some error. Host does not name a type. Ah. Yeah, that's really obnoxious. Fine. Work. .cu. Not one. Or CPU. Yeah, so obviously this isn't available. Yuck. Okay. I think I can do this for now. But when does the CUDA arc get defined? I guess it gets this gets added by NVCC probably. To find better way to conditional. And that's the wrong comment language. Okay, cool. So we now have this training on CPU. We'll see, we should at least let it run a little bit to make sure that the results are the same. But they should be, since it's now literally running the same code. And that looks pretty good. And it's very funny to me that this feels slow because it's running on CPU, but this is running like 20 times faster, generously, than the majority of RL research. So there we go. We have CPU, we've got GPU fallback. Well, we have GPU code with CPU fallback. That's not bad. We'll have to clean this up over time, obviously, but at least we now have this for debugging purposes. Yeah, and this is matching the learn curve as well, so we're good. And if I run this one, hopefully this still works. And CPU. GPU kernel plus CPU fall for GAE. All right. So that nicely cleans some stuff up for us. So we can just delete this now because we no longer need this. Gone. And I'm going to just go ahead and put this into PufferLib.cu as a comment. All right, I'm just going to put this in here as a comment. To worked from Python. Now we no longer need this. So that will get this substantially shorter. This doesn't need to be global either. I don't know why it's there. So we're now down to 1075 lines in clean PufferRL with that. Not bad. Not bad at all. Yes, we still use default dict, we still use a few other things, but it is substantially better. It's 1:27. I'm going to use a restroom real quick. I'm going to grab a new cup of tea. Maybe just get some hot water for this. And we're going to continue on and keep cleaning up this file. And then this should be in a pretty good spot. Be right back. Okay. We are back. Did it kick me offline or is the UI just broken? I think the UI is just broken. The heck? Oh yeah, there, we're good. Okay. So I think I realized what's happening with the replay buffer, by the way. So it's kind of an on-off policy issue. It depends how you define it. The problem is the value function, though, not the policy. It's not that the policy is stale. The policy is fine. It's the value function. So the issue is the value function is going to get newer. Hang on. Does that make sense? Yeah, so the value function is trying to predict what's going to happen at each time step, basically, when the policy does its thing. But when the policy gets fresher, the value function hasn't caught up yet. So, like, the policy optimizes just fine on this, but I think it screws up the value function. I think that's what's going on. I'll have to really work through the math details more, but it's fine. What we're doing with experience filtering, A-OK. In fact, yeah, what we're doing with experience filtering is A-OK. The replay across epochs, not so much. But, like, we can keep it like this for now. This should be basically fine. And then I will start thinking about what modifications we would need to make the full experience replay work. But we have it implemented now and we can do it. So that's solid. I think now we take a look at this at a high level again and we look for more things to improve on. And then we fix a few of the like annoying bad pieces of code that are in here. And then we fix like E3B, diversity all you need. We fix those algorithms. And then we should be good. The losses we have are kind of screwy here, right? Loss is kind of screwy. Episode buffer. Maybe there are a few lines we can cut out overall, but this is like pretty dense. E3B, diversity all you need. Yep, we'll need those. P30, also that. Needs to get updated. Learning rate schedulers, AMP, profile, dashboard. This crazy thing, again, we're still going to punt on the structure of this file. Whether this goes in a class or whether we have some better way of doing this, we'll see. Why not on Twitch? I am on Twitch. I'm on X, YouTube, and Twitch. I believe it's Neural MMO on YouTube because that's the channel that blew up. Yeah, it's on Twitch, X, and YouTube. Twitch username is the same as the X username. The YouTube one is Neural MMO. Because that's where I posted my thesis, so that's the channel that blew up. Alright. Little bit of shenanigans here with how we're managing how we're managing H and C, LSTM state. Little bit verbose with how we're doing NVID. A little bit of screwiness with the masking and whatnot. Nothing like major that I see though. We've got the state. Yeah, it's mostly just DI, AYN, and E3B being screwy. And cool, then the store happens, info log happens. And this is kind of fine. And we have this stuff, which occasionally people send us like NumPy arrays and shenanigans. It's kind of fine either way. Data stats. And then this stuff for zeroing the experience buffer. I don't think you need to do this here. I think we can do config data.config profile variance. I think we can do this when we log the losses, right? Okay, zero the losses out. Back up to the top. Is there not like a cross entropy? Cross. So this is, was it fork.nm.functional.cross entropy? I can go there, we no longer need that mess. Then we have our total mini batches here. Accumulate mini batches and just n samples. So this is P30. The PPO one is one line. All this will eventually get moved into the kernel most likely or whatever, so this won't be a big deal. Then you get your sample, your batch. Action is batch.actions, LSTMH, LSTMC. Then you do train. You update the values. LSTMH, LSTMC. I don't think we need these anymore. Yeah, we don't need these updated anymore because we're only doing single segments. Maybe an issue, maybe not. And get our log ratio. KL clipping. This is algorithmic stuff that we need to ablate. We have P3O loss, we have clipped V loss, and then we have normal V loss. We have entropy loss. This diversity all you need shenanigans thing. Scalar backwards, a few extra metrics. Rad clipping. This one. Is there anything better we can do here? I can't see a better way of doing this, actually. Which is quite annoying. Then here's the KL target. Reprioritized experience. It's fine other than being really way too long of a line. It's going to be data.auth policy rows. You got your learning rate scheduler. You got this thing. You got mean and log. Then you've got your losses zeroed and checkpointing. Okay, then we have the storage function. We already went over this quite a bit. There are some small tweaks needed, but quite small at this point. You go over the sampler. Sampler has a bunch of different options that we don't know which ones to keep yet. There's some logging that we went over. Some artifact stuff that hasn't been updated in a while. Profilers, kind of difficult to get around some of this mess. But these aren't a big deal. I think I probably want my checkpointing code above, don't I? Yeah, I kind of want all this code like above where it is now. Yeah, utilization, profile. Close. Yeah, that's a better spot for it. Okay, 1073 lines. Rollout needs obviously to be cleaned up, but the vast majority of messy stuff in this file is now being caused by like algorithm hangers on that we haven't finished evaluating yet. Mainly E3B, diversity is all you need, and then the P3O stuff. So when we end up keeping like one path, one code path, it will be shorter and substantially cleaner. Let's go double check. Let's go double check breakout overall now. Hang on. Breakout. Play. No. Let's get a breakout curve. How is this suddenly broken? Is this not commented? Oh. That's silly. I just missed. Okay, that does work. 1.4 mil. We will see score. That looks good to me. 52 million steps. Solved in basically 60. Yep. That's pretty well on par with the previous best. So we're very happy to see that. And then uses. So max usages of a sample, it got used like 10 times. Average sample gets used once. So that is basically just advantage filtering. Yeah, the prioritized experience in this case just becomes advantage filtering. And let's make sure really quick that the sample-based metric is in fact better. I believe it will be like way better, but we will we'll just make sure real quick. So this is now selecting selecting the best samples, just sorting them and taking the top ones instead of assigning a probability distribution. And I believe this still runs, but it's not as good. I believe that was the conclusion. Is there any reason that this would be abs.sum, abs.sum? Yeah, so this is a good comparison, and it's it's much better to sample, apparently. We should also get a rand one for comparison. So this should just be, was it random? And I think that it's going to be similar to the prioritized for this environment. But we should definitely check. Random will be very close to the original PPO. It's just, instead of going over chunks of samples, you're randomly picking your chunks. And there is a bit of copy overhead. I think it's very similar in perf. Yep, so prioritized, not prioritized, very, very similar. Max uses of 7. I don't know about that. Oh, it is random sampling. Okay, so yeah, it is possible, like, yeah, that's reasonable. So it's not a huge difference then. You know, it's not really deciding to reuse samples way more often than it would randomly. So it makes sense that these two are pretty comparable. Okay. We leave it now. We leave it for now. So I guess then the next thing is just going to be to start fixing E3B, diversity all you need, fix those up, and we can start running real benchmarks, right? Fix all the machines, and get this running on stuff. There is also perf stuff to deal with, though. There is also perf stuff to deal with. Hang on. We'll see the copy overhead on this. Okay, so copy overhead is very low for training. We have quite a bit of copy overhead now in eval that wasn't there before we did this stuff. Yeah. Make sure this is getting measured correctly. Okay, so this is eval copy right here. We have store. It's going to be these copies right here. I mean, I looked at a ton of different ways to do this, and I don't think there's a good way around doing it this way, though. If I store it the other way, then it'll be slower when I go to access it. Well, how bad is it on like a real end, right? Okay, we are pretty much all in learn. With copy creeping up a little bit. $250K. Let me try a couple quick things here. I think this might not be optimized because this is half the speed it should be. Yeah, something's screwy with the way that this is being sampled. Let me see what the batches are. $20.48 by 16. Uint 8. That is how I had it before. Wait, 2048 times 16. That's weird though. That's bigger than it's supposed to be allowed to be. Max mini batch size is 16K. This is data.mini batch size. Okay, that's better. Does this account for the difference though? I don't think it does. Oh, there you go. There's your perf back. And then we'll see what copy converges at. Yeah, I think that's not a bad haircut to perf overall. There's definitely copy bandwidth to optimize, but I think we got out of this pretty well. $65 and $33. But we're not capturing, you know, something's not getting profiled because these numbers don't add up, I'm realizing. So the SPS is roughly fine, but these numbers don't add up, which is not good. Neither of them add up at all, actually. So there's something that's taking time and isn't getting profiled in both of these. Let's see if we can find it in eval first. Okay, so we got profile misc, eval forward, eval copy, eval. Yeah, this entire function's inside an eval, so I don't actually know what it is that's taking up the time, right? Oh, it's probably the, hang on. Where do we do the synchronize call? So context enter, amp context exit. Okay, so this has to go up top. And this has to go here. Synchronize, yeah, it's got to be like bookended. And that should give us better calcs. We will see. That looks like it adds up now. Yeah, that adds up now. %10 copy overhead, 18% in forward. At least we have good stats. At least we have good stats now. Real quick, just for fun. What if I don't do any of this? Does this actually affect perf? We're at 428. Oh yeah, that takes a little bite out of the perf, doesn't it? So we have to actually optimize the profiling a bit, and we get some of our time back. About 5%. That'll be an easy perf win. And that's most of the perf back already, just from that, if we do that correctly. Let me think how we would do that. I think we can't do that until we update the dashboard a little bit. But we know that that is a 5%er waiting on this. Okay. So perf not terrible. I think we fix E3B. We fix diversity all you need. And we probably were okay to start running experiments. It does concern me somewhat, the well, no, never mind. We need to rerun those experiments before we can make any conclusions. So let's just get E3B in all like the other algorithms working for now. Okay, so we get some errors. I think I know what we're going to do to clean this mess up as well. Have to move some data around. And we'll see if I get stuck on anything, but seems pretty simple. All right, so that runs with a massive hit to perf. We'll check what this does. Is that everything though, really? I didn't have to mess with it and train it all? Oh no, E3B is the easy one because it's only it only adds rewards. Yep, right there it adds the reward. Perfect. Crazy amount of overhead this thing adds, though. I will be interested to see how it scales, if it's bad with bigger policies as well. Doesn't hurt the curve that much, but doesn't really do much for you either. %66 forward time to E3B. Let's see how it scales under LMMO3. CUDA runs out of memory, that's funny. Yeah, what do we do about that? I didn't plan for that. I guess we go to like 2Ms or something. Holy, that is slow. Let's just make sure I didn't slow it down a ton because of the 2Ms. Yeah, no. Sec. Send a message real quick. Let me actually just put that in the Discord real quick. Where's the mic? I think it's this one. .512 by 512. There we go. All right, so E3B, not too optimistic about. We can get the other algorithm working, though, because that one I actually think that there's something to it. Probably E3B, there is a way to make it work, but it's like very slow. Very, very slow. Okay, these are going to be archive skills batch. Archive skills batch. And the code's not going to look like this for forever, but this is for the initial port. Oh. I guess we have archive. This param is. I think that'll do it. Does this go into there? This is size total agents. This is size experience rows. So this one probably does go in there. Diversity, I need skills. And then batch. I could probably just do it like, zero experience rows. Skills batch, and the archive is the only thing that needs to go into data. So this is eight. Expected batch. Let's see. And get these shapes to match up. Eight one nine two. Yeah, this is fine. This is a flat state hidden. Oh wait, no, that's not fine. You want this to be batched as well. You really want this to be batched as well. Oh, we can just do this, right? Let's not have it do this. Batch time. Sample logits. Why would that affect logits one bit? This happened on like second batch or something weird. Nope, that happened immediately. Okay, we have logits. Got batch actions. Why are these suddenly not flattened? That's very weird. Oh, because you did this, stupid. I see. There we go. See. So we got Q, we've got Z indices. How did this get added to the observation, though? Where'd that even happen? Z indices up top? Batch dot. That's only 128 of them. I guess this is state Z indices, right? Allocates discriminator. Where's the extra observation, though? Encode. Where's the extra observation? I thought we add to the ob space, don't we? Confused now. Yeah, you pass here to that, right? You pass in Did I screw this up somehow? I thought we were passing the input of this to the policy. Let me go double check how I had this in dev. Oh, so how close are we to 2K? $19.18, pretty close. Pretty close. Star Puffer helps us out. Okay, so just add this somehow. I don't see anywhere where I'm adding this as an observation at all. See how I was doing it in here. Also, the dev branch of this is 1200, and this one's 6. Is that right? Yeah, this has gotten way too long. 400 lines extra. So we definitely need to cut this down. Okay, so here is where we compute observations. Here's the indices. This doesn't go into state at all. Oh wait, no, here it does. It does go into state right there. And then policy. Does this not augment the observations? I could have sworn that's how it worked. Oh, you know, maybe it's in the maybe it's in the LSTM or something. It's not in here either. Well, let's at least get it to run for now. Yeah. How do you unsqueeze a dimension like that? Yeah, dot expand. See. Okay. I just want this to run for now. Okay, there we go. This still runs. Cool. Yeah, so this still runs. We have all these things ported and running. There's still P30 to do. I am going to need to still do some work on that. But this feels like enough porting for now. Okay. Next, we get to run 2 experiments. I like this. Okay, good. We don't have any weird stuff in here. So first one of these is going to be with prioritized, or what is it? Prioritized filtering. Then the next one will be without. And that'll give us a good eval. And then we'll do a couple other things with this just to make sure things are working. And then I think we'll do some thinking about algorithms. Yeah. All right, I'll let this run. I'll be right back. Okay. Scores here. We let this do 100 mil. And then we do the other one, which will be method random. This will be the comparison run for random sampling versus prioritized filter. This is one of those methods I would expect, I will say. So it will be surprising if this doesn't at least maintain perf. That's a bit disappointing. Not clearly better. Unless it pulls ahead. There are a couple of variants we should try as well. Low absolute advantage. So I did do this correctly. Low absolute advantage. Appendix C for details. Okay, so they're still using Atom. So we can beat that straight up as is. And then advantage filtering, you collect rollouts. You compute advantages. And then max absolute advantage. A max equals okay, so they're doing like a direct filtering thing instead of doing we have a sample based thing, they have a filter based thing. Those should both be fine. Oh, did this do something? Hey, it did something. Look at that. It did something. Yay. That's cool. So on the harder task where stuff is like, stuff gets sparser over time and whatnot, it actually does something. We're happy with that result. We take that. That's a win. That's a pretty big win, actually. Look at that. So I wonder if that'll help on neural MMO. I gotta send this over. Go just link somebody one paper. Okay. We're happy with this. This is a win. This is a solid win. In fact, I'm going to let me send this to Aaron. Solid. Now, I think what I want to do, I want to do something a little bit out there. I kind of want to just take some time to gather my thoughts, kind of go through a bunch of the things on the algorithm side that have been floating around my head, just write down a bunch of random throwaway notes, and basically just see where I think we should go next with all this, because this is going pretty well so far. What are some things that we know to be true? Generalized vantage estimation locks you into per-nth hyperparam search for gamma. Lambda appears to be a bit more stable. Filtering. Let's win. Prioritized experience replay. Because, was it the value function lags? The value function lags. No, it's the policy lags behind. No. Oh, yeah, because the... Word obtained by an old policy. Old policy. Prevents you from reusing old data to train the policy, though. So it's the value function that gets screwed up. Two. Okay, so these are a couple things. Noise-based exploration methods don't work. Count-based exploration methods work, but are specific, and then E3B might be able to work, but it's slow. Can result in visually distinguishable behavior. discriminator trained on logits prone to jiggle. Fitting jiggle. Actually, is there a stop grad on that? Hang on, is there a stop grad? If there's a stop grad, it wouldn't be. I think I tried it with a stop grad though, and I couldn't get it to work. Yeah, you can't do it with a stop grad because you have to be able to influence the policy actions. That's the whole point. So yeah, the formulation is weird, but the method is good. Okay. Dreamer V3 tricks are bogus. Something in world modeling lets you scale to big policies. These are things I know to be true. P3O was not a clear win. Self-play can be an easy curriculum, auto curriculum. Competitive self-play is prone to policy collapse. Historical self-play can help. Training multiple. So what I'm kind of looking for is a way to tie all this stuff together. These are what I believe to be facts. What is the minimal change to PPO that I could make that would make prioritized experience replay work? All right. Recline a little bit here. Thinking mode. There we go. So the issue right now, when you compute generalized advantage estimation, right? That advantage, you can look at the value function as essentially learning to predict discounted return. That's not quite accurate. That's only true for lambda equals 1, but it's about that. And it's discounted return under the old policy. That is the problem. So there's actually nothing preventing you from, if you like, just ignore the value function, right? If we just look at reinforce, let's look at reinforce. Where's the spinning up one? Okay, so actually you already have a value function in vanilla reinforce, it seems. That seems weird. I thought original reinforce didn't have a value baseline. Yeah, they updated this. This is not vanilla policy gradient. This is like... Is this really vanilla? I thought the vanilla you just used the returns directly without a baseline. Because if you use the returns directly without a baseline, let me zoom this thing in. If you use the returns directly without a baseline, there's nothing that prevents you from reusing the samples as much as you want, right? You're not reusing logits, you're recomputing the forward pass logits every time. So when you get into trouble is, I think, with the value function. It's kind of backwards. The problem isn't the current value function, it's the current policy. So you got the trajectories under a specific policy, and then the value function, this is a little tricky to think about. The value function attempts to predict discounted return under the current policy. So it's if you're in this state and you act with the current policy, what are you going to get? That's going to undershoot though, because as soon as you start updating the policy, right, that data is now from an old policy. Now, crucially, like, you can keep using that to train the policy. Nothing bad should happen there. The issue is that the value function is going to be off. Because it's you can get like an optimal value function for the old policy, not for the new one. Now, it shouldn't change that much, right? From one batch of data, like you can only update the policy as much as is allowed by a batch of data. But if you start using like historical buffers, that is no longer the case. I don't think replacing the value function with a Q function helps you either. That just gives you one additional step, right? So a Q function says, it just gives you the value for all actions. But then it assumes that after you take this action that you follow like the best policy or whatever. So what happens if your policy, let's say you have a Q function for your policy, right? So no value function, the policy just is a Q function. We'll ignore continuous for now. Does it magically work? Well, you go to the very end. No, it shouldn't magically work. Because the last step you say, okay, you train the Q function with the action that you took. That's correct, that it gets the reward. But as soon as you go back one additional step, I think you're off again. How does this work in in DQN, for instance? I mean, they don't have trajectories here is the thing. I don't think this is going to be helpful. I think it's way simpler here. How sad is it that there are so many things and there's not even the archive paper? There we go. I mean, this gives you implicitly discounted returns. Doesn't include JE. Well, if we look at what if we look at something that actually works? Try to see how they handle this. Actually, the code's probably in CleanRL for this, isn't it? Though this probably doesn't have recurrence in it. How long is this? It's only 300 lines. Okay, so they have QNet and then they have the actor. They make, oh, do they use, where's this replay buffer come from? Oh, they use SB3's replay buffer? Come on, that's not CleanRL quality for you. training. I think I really just need to understand exactly where it is. Where's the line that lets you go off policy? Large continuous domains. Okay, so this is... Part of this is handling continuous. Soft value function is trying to minimize squared residual error. We have that. Policy parameters. I don't think I need to go this far to figure it out. But I should figure out this as well. Essentially, the question I have right now, right, is just... I found that the off-policyness of PPO isn't quite a problem in the way that it's usually thought about, though there is still a problem with the value function. I'm trying to figure out how you get around that here. Also, these things don't have JE, do they? They don't have generalized advantage estimation. Yeah, I don't trust these baselines either versus, I don't trust these experiments either is the thing. Who was this paper from originally? Sergey's group? How many experiments do they have? Yeah. Not really anywhere near as many experiments as you would want. I think that the way in which off-policy algorithms do discounting is linked to what I'm looking for. I don't see a discounting factor in here, do you? Where's the discounting factor? Is there no discounting factor in here? There is no discounting factor in soft actor critic. That immediately makes me suspicious. Oh wait, args.gamma. What's gamma? Ah, there is a discount factor. Good. Okay, I'm not completely insane. Where is data collection? Okay, you step a whole bunch, right? And you add to the rollout buffer. And then, okay, they're doing, yep, so this is the collect, and then here's the step. You sample, you train the critic, and the objective of the critic there's no loss being computed here. This is no grad. So basically, it's just this chaining forward thing. All right. I'm gonna use the restroom. I'll be right back. Keep thinking about this. Okay. the key thing that I'm not sure about here, right? We're trying to replace GAE ultimately. GAE is really obnoxious because it requires that you roll forward. Fix the chair. So GAE is really obnoxious because it requires that you roll forward trajectories. You can't really train until you get to the end. And that seems essential. Where's SAC been used, though? Has anybody done, like, SAC on Atari? Random paper. So this is versus rainbow. Actually, maybe that would be better of a comparison. I just don't trust any of these papers is the problem. There's this monstrosity. So difficult to compare stuff like this, though. Multi-step returns. And this is Atari as well, which is not. Man. So the thing that's difficult here, right? Generalized advantage estimation works really, really well. In fact, the more stuff you do with PPO, the more it's like generalized advantage estimation is most of PPO. But then off-policy learning doesn't use generalized advantage estimation. They really only have one discounting factor as far as I can see. So they kind of do like this one-step thing. This is multi-step. Forward view multi-step targets can be used. Okay. They have their multi-step thing, but I think it's like 3 steps, right? Yeah, 3 steps forward is all they go. It's so sketchy. I might really have to go through a bunch of literature in order to figure this type of stuff out. I think what I'm going to do is I'm going to just spend, it's 3:36. So I'm going to spend a little time on this now. I'm going to see if anything sticks out to me, and if not, I think we will focus on trying to finish and ship this update with muon, with cosine annealing, with all the perf enhancements, with advantage filtering, with good experiments and baselines, all of that. And then the next update will be really seeing if we can fix algo side. That's going to be like an ordeal though. Obviously, I'm going to have to go through all this in details. But, quick summary. Splitting action selection and value estimation. Okay, so this is kind of analogous to the shared critic thing. And this has evidently made a very large difference. The largest, in fact. Okay, what about distributional? Full probability distribution. Discretized into bins, okay. So this is kind of the biggest one then, right? This thing should have OCR, right? Do they do drop ones? They did do drop ones. So no distribution hurts a lot. Oh, actually, yeah, it's a little unintuitive here. A lot of these things hurt a lot. Dueling doesn't matter. Double doesn't matter is very weird. I guess it's covered by the other ones already. So the biggest things are noisy, multi-step, distributional, prioritization. The distributional thing matters a lot. This thing can't see. Wrong line, buddy. Yeah, so distributional seems to be the big chunk there. Multi-step also makes a big difference, but only for like 3 steps or whatever they tuned it. I was looking for a specific paper. Really need to be able to replace GAE as the thing. Well, hang on. The heck does this even work? You have DQN, you train transitions. I really just, the thing is I need to understand very, very precisely what it is that lets you do, like off policy samples versus not. And the tricky thing with this is like, none of these use an LSTM. Does that matter though? No, because you still end up with segments in PPO even if you don't have an LSTM, right? You still end up with segments. You can sample them in whatever order you like, but you still end up with segments because of the GAE computation, right? Okay. So what prevents you from doing unlimited sampling on that in that case? see. So you collect your samples. You have like pi of obs. You get your probability over your action distribution. Then you have value function, obs, I don't know, v sub o or whatever. Off policy, you get q. I don't know what notation I'm doing at all here, but we're going to keep going with this. When you train on policy, you train value to approximately equal like gamma I r sub I, something like this. Whereas with the Q function, you kind of do this implicit thing, right? And the equation. I want to make sure I get the sign right. Yeah, there it is. So it's R plus gamma Q and then here the value is equal to Ri Q St minus T1, something like this, right? And then this is a distribution, so presumably which action do you use here, though? Oh, this is max sub A. So I see. So this is the maximum. And this one's max sub A. So maybe this is it. How is this not still dependent on the policy? I think this should still be dependent, no? Because when you get to the next state, what action do you use? A. This A has to be the action that you actually took, right? Oh, wait. Okay, I have this wrong. So I have this wrong. I haven't done DQN in a long time. So let's just erase this portion. So this is going to be Q X Q S and then this is minus the one that you actually took, A. Okay. So this is the difference between taking the best action under your current value function and, or your current Q function, whatever, and the action that you actually took. So this is the thing I think that gives it to you. But the thing I don't get here, right? The Q function just tells you it's like a one-step difference. The presumption is that you follow either the best policy or the sample policy, whatever you're training against. How do multi-step returns work with Q learning? They saw that in Rainbow, and it was very important in Rainbow. Oh, so this is just straight up skipping steps, right? So you do discounted return, kind of, but only for a few steps. And then this is gamma at t plus n. Doesn't that look familiar from JE? I think that looks familiar. Isn't it this? This is this component in the middle. Then this is gamma to the k. Yeah, so this is identical. This is the n-step advantage right here. Or, yeah, this is the n-step advantage. There's no lambda in here yet, though. So this is before you introduce lambda at all. This somehow disappeared when they summed it, though. Oh, this is under the max action, though, here, right? Look. So this is different. Yeah, but I think this is still broken. Because how you get from st to t plus n is dependent on the current policy, right? I think that's still broken. That seems like a hack. Maybe this is why they have such short returns. They only do it for a few steps. So I think your actions can diverge. And this is a huge part as well, look. Where'd the ablation go? No multi-step is down all the way there. let me make sure I understand this correctly. So this is your Q function with the current set of parameters, state and action. And then you have the max over the Q function and steps ahead. That's the value function, basically, right? Whenever you take max over actions, that's just the value function. Or something similar to it. It depends on whether you take max or whether you sample in your value function, but very similar. And then this one is also value function. Slightly better, I guess, because you get to know what action you're going to take for one step. But yeah, it breaks in the middle, right? Now, I guess the difference here, right, is you only have like 3 steps to go wrong. And then if every sample looks like n steps ahead, they sort of get chained together, right? And you're never off by more than 3 steps. Is that how that works? I understand, I think, now the 1 step ahead case, right? So the 1 step ahead case, is the DQN? Yeah, it is. This is DQN. So the 1 step ahead case, you have, what's this? Gamma next state minus current state. So this is the value function. But in this one, you get the action condition value function. So basically, if you don't have a Q function, right? If you're just using a value function here, like PPO does, then the action that the policy is going to take can change, and then the trajectory changes. So you're optimizing the value function over a trajectory that the policy is not actually going to take. But here you say explicitly, if the policy takes this action, right, this will be the value function. So it's not dependent on the actual action that the policy takes. Now this still is, right? This is just unconditioned value function. But this is only 1 step ahead. And then the idea here is that you train this transition, and then if you train the next transition, well, the next transition also has this. So if you're training all these transitions individually, they all chain together, then it works out. Now this multi-step thing, I think if you make n large here, this breaks. Because you have the exact same problem as on policy. But they kind of just punt on it. They kind of just punt on it anyways. And it only gets a few steps ahead. Can you just do this with JE? You can technically just do this with JE, right? But the thing is, the segment lengths are still really long. Hang on. Why do we need such long segments in JE but not here, is the question. Why does online need long segments and this doesn't? Okay, as this goes to infinity, yeah, you get this. Did they cut out a term here? I think they cut out a term. They assume this goes to infinity, don't they? Yeah, I think that this case with 1 actually goes to... They miss this term, don't they? They just assume that it's going to be infinite. Yeah, see, they're going to infinity here. So if you don't go to infinity, gamma 1, I think you recover this. Negative VST plus, yeah, so you get this. So this term, they dropped. And this is exactly what DQN is going to use. And they keep this term only like 3 ahead or whatever. They keep this term as is. That's what the max over actions does, essentially. It turns your Q function into a value function. And then this one's kept as a Q function and is conditioned on the action that you actually took here. So if this is one step look ahead, which is this one, oh yeah, this is the one step one. Okay, so yeah, now if you take this one here, then this is value at next state, this is Q function, and then this gives you perfect off policy training. This gives you perfect off policy training. Because if you go one step ahead, this value is going to be conditioned on the action that you actually took. So you're no longer relying on the policy to take this action because you're explicitly conditioning the value function. I think that's correct. Do you just straight up sub in a Q function for a value function and have it do better then? Because you kind of already get double DQN out of this, don't you? Let me see. Where is that summary? Splitting action selection and value estimation between two networks. Main network selects the best action in the next state, then evaluates that action's Q value using a target network. Main network to select the best action. Let me see how they set that up. Assigning each experience randomly to update one of the two value functions. One set of weights is used to determine the greedy policy and the other to determine its value. I think we can just replace the value head with a Q head, right? Oh, got a thing to do pretty soon. I think we can just replace the value head with a Q head though. I think that's the finding. We can do this for all discrete M's. Right? Yeah, we can do this for all discrete M's. I think that'll be a next thing to try. I don't necessarily know if we're going to do this immediately. It might be better to like get some experiments in on the current thing, because this should let us do prioritized replay. But there is, I think there is a big trade-off. Also, let's take a moment to appreciate the 1 week of training for 200 million frames, where we currently, for 200 million frames, states, I guess, on our re-implementations, it takes about, I don't know, 3 minutes. So that's pretty cool. 4 minutes, maybe. So I think that's the finding. I think the finding is you should just be able to replace the value function with the Q function. Does that ever hurt you? I think it never hurts you. It makes learning maybe a bit more complicated. I mean, like the code a little more complicated. The thing that's tricky though is like you only really can do off policy when the multi-step returns are pretty short. I guess the question is, why does Rainbow work so well then, right? Yeah, you use the baselining that happens. That requires V and not Q. V is just equal to, V is just Q of max action, right? Q is just action condition value function. You can recover V by taking the action of the policy. And that's you, Aaron. Hey. All right. We got to chat, right? So I'll be back in a couple minutes. Use the restroom, grab a drink, all that. And maybe grab a half sandwich real quick. And I'll be right back in a few minutes to chat. So for the other folks watching, I will probably be back for an evening session. I don't know if I'm going to implement this stuff immediately or if we're just going to try to get everything into a better, stable state. But all my stuff's at puffer.ai. Closing in on 2K stars. Please go ahead and star the repo. Really helps us out. And you can join the Discord to get involved with dev. It's not all staring at math all day. There's plenty of cool dev to do. You can follow